Hello student, welcome to Chemitarian. Topic of the day is Bohr's atomic model. Okay, so in this class we discuss Bohr's postulates of Bohr's atomic model and calculation of radius, energy and velocity. Okay, so before that we have to learn some important formulas. Okay, so some important formulas are formulae are Coulombic force. First one is Coulombic force, which is equals to Q1 Q2 upon R square, where Q1 and Q2 are magnitude of the charge and R is the distance between the charge. Second formula is centrifugal force, which is mv square R. M is the mass of the object, v is the velocity of the object, and R is the radius. And third one is angular momentum, angular momentum, which is equals to angular momentum, which is equals to mvr. Okay, angular momentum, which is equals to mvr. These are three important formulas we used in the Bohr's atomic theory. Okay, what is the first postulates of Bohr atomic theory? So the first postulate of Bohr atomic theory is about the nucleus. Okay, according to Bohr's atomic theory, atoms has atoms has a nucleus where all the protons and all the neutrons, all the neutrons are present. Okay, all the protons and all the neutrons are present, and in this the size of nucleus is very small. The size of nucleus is very small, and it is present in the present in the center of atom. Present in the center of atom. Okay, so let's suppose it is a atom. So atom is a spherical where in the center all the protons and all the neutrons are situated, and this portion is called as nucleus, and this portion is called as extra nuclear part, where all the electrons move. Where move? Imaginary circular path, and this imaginary circular path is called as orbit. Okay, so all the electron move in the imaginary circular path orbit, and all the protons and neutrons situated in the nucleus. Okay, and nucleus present in the center of the atom. This is the first postulate of the Bohr. Okay, now the second postulate is the second postulate is the negative charge electron, the negative charge electron, negative negatively charged electron are revolve are revolving nuclear negatively charged electron are revolving around the nucleus, around the nucleus in in the same way as the planets are planets are revolving around the sun. Okay, and that's why it is also called as solar system model of atom. That's why it is also called as solar system model of atoms. Solar system model of atom. Okay. Now, these are the second postulate where all the electrons revolve around the nucleus as planets revolve around the sun. Okay. So now, why electron does not fall on the nucleus? Because there is attraction force attached in this. So there is two force. In this system, there is two force. One is the attraction towards electron and nucleus, and one is the centrifugal force outside from the nucleus. And the magnitude of the both forces is equal. Okay, that's why electron does not fall on the nucleus. Okay, so what is the path of the electron? So path of the electron is circular, and this path is called as orbit. Of course, you know. Now, the attraction, attraction force towards nucleus, the attraction force toward nucleus is equals to centrifugal force away from nucleus. That's why electron doesn't fall on the nucleus. Okay, so attraction force, electrostatic attraction force is equals to centrifugal force. Centrifugal force. This is the second postulate. Now third postulate, the third postulate is that electron, okay, there is multiple imaginary circular path. Okay, there is multiple orbit present in the extranuclear portion of the atoms, but electrons can revolve can revolve only in those orbits where whose angular momentum whose angular momentum mvr is integral multiple of h by 2 pi. Okay, so only in that orbits electron can move. Okay, so according to this, mvr is equals to nh by 2 pi. Okay, for the first orbit where electron can move, n is equals to 1, so mvr is equals to h by 2 pi. For the second orbit, n is equals to 2, so mvr is equals to h by pi. Okay, now for the 3, it is 3h by 2 pi, 4h by 2 pi, and so on. Okay, so on. Now, the fourth postulate is the orbits in which electron can revolve, the orbit in which electron can revolve are known as are known as stationary orbits. Okay, and in stationary orbits, the energy of electron is constant. Okay, so in the stationary orbit, energy of electron is constant. Okay, in the stationary orbit, energy of the electron is constant. Okay, fifth postulates fifth postulate is that each stationary orbits have each stationary orbits orbits is associated with associated with fixed amount of energy fixed amount of energy fixed amount of energy. Therefore these orbits are also called therefore these orbits are also called these orbits are also called called energy levels energy levels. These orbits are also called energy levels. Okay, and numbered as 1, 2, 3, 4, 5, 6, so on, or in alphabet K, L, M, N, O, P, and so on, from the nucleus outward. Okay, this is the fifth postulate. Now the sixth postulate is that when electron jump from one orbit to other, when electron jump one orbit to other or jump from stationary orbit to other orbit, it either emit or absorb some amount of energy. Okay, so delta E is the energy change, E is the final orbit or final state, minus E is the initial state. Okay, so these are the energy orbits. These are the six postulate of Bohr's. Okay, so according to Bohr's, there is a centered circular nucleus situated into the center of the atom where all the protons and neutrons are just situated. Okay, after that, in the extra nuclear parts, at in the extranuclear portion, an imaginary circular path situated which is called as orbit, and every orbit is assigned with a certain amount of energy. Okay, but electron move in that orbit only where the MVR is equals to NH by 2 pi. Okay, and the energy orbits are known as KLMN or 1, 2, 3, 4, 5. Okay, and when electron move any certain orbit, the energy of orbit is fixed, and the this orbit for this electron is called as the stationary orbit. And when it jumps one orbit to other, so it either liberate or either absorb energy, and the energy changes E final minus E initial. Okay, these are the concept of Bohr's atomic theory. And you have to notice one thing, like if first excited state, that means n is equals to 2. For the second excited state, n is equals to 3. For the third excited state, n is equals to 4. So on. Okay. So first excited state means electron move in the second orbit. Okay, second excited state means electron move in the third orbit, and third excited state means electron move in the fourth orbit. Okay, now some important calculation. So first calculation is radius. Okay, radius of Bohr's atom. Radius of Bohr's atom. So as we know already that uh, attraction force of electron and proton is equals to centrifugal force. Centrifugal force. That's why kZe square upon r square is equals to mv square upon r. Okay, so 1r and 1r. Okay, now mvr is equals to nh by 2 pi, nh by 2 pi. So v is equals to nh 2 pi 2 pi mr. Okay, and now v square is equals to n square h square 4 pi square m square and r square. Now put these value. Okay, put this value from this equation. So according to this equation, v square is equals to k z ka square upon m. Okay, that's it, equation number 1, and that is equation number 2. Because one left hand side is equals, so we got k z ka square upon mr is equals to n square h square 4 pi square m square and r square. Okay, now MVR and 1M and 1R. So we get R is equals to N square H square 4 pi square M 4 pi square M K Z square. Okay, putting the value of putting the value of the constant. So R is equals to N square, H is the Planck constant which is 6.62 into 10 to the power minus 34 square upon 4 pi is 3.14 ka square into m 9 into 10 to the power minus 31 mass of the electron 1.6 into 10 to the power minus 19 and k is 9 into 10 to the power 9. Okay, and we got the value of the radius of nth orbit is 0.529. Here is z 529 n square upon z. Angstrom. This is the formula. Okay. So for second orbit radius n is equals to 2. So radius of the second orbit is 0.529 multiplied by 4 upon, suppose it is for the helium atom. Helium He plus ion. So 2 it become 1.1 angstrom. Okay, so the radius of the second orbit of helium is 1.158 angstrom. Okay, these are the formula. We will calculate energy and velocity with some question in the next portion. Thank you.